Okay, so today we are going to continue our system design concepts. So today I am going to talk so basic from where we can start learning some principles, some concepts. Okay, so as you know, whenever we talk about the system designs, so before system designing, we should, as a software engineer, our responsibility, we know the basics of some principles. Generally, nowadays, whenever we are going to build any application, any software, we follow some kind of methodology. Maybe while building, implementing, or any applications, we follow some OOPS principle, object oriented programming principle. Maybe sometime we follow the functional programming principle. So as a we know whatever we are going to design system, in short, finally they are going to the implement. So while implementation, there are some specific principles. So these are the very basic principle we should know. So today I'm going to talk basically about the object oriented programming principle, and these principles are very basic. Even you can say uh, anyone going to launch any programming language, object oriented programming language, they start learning this concept. So these principles, object oriented principles, it's also help while the system designing. This also play a very crucial roles to making our system as so modular, maintainable, and scalable. So if we talk this principle, we are going to talk. There are lots of principle about the OOPS principle, but surely we are not going to cover each and everything. But some of the very key and important concept we should aware, we should know. So let's going to talk first basic principle. That's as a encapsulation. So this principle tell us about uh, the first things. Whenever we're talking, we are going to implement our application as a object oriented programming, object oriented paradigm. Here, everything considered as an object. So maybe employee object, department object, different kind of a model object. So whenever you are going to define a model, any object, so generally each and every object generally have a kind of a two behavior. One is the behavior what this object doing, and another is the property like from which elements these objects are made. For example, let's example a pen. So pen is the one model, pen is the one object. Okay, that's made some different components, maybe plastic, needle, something, right? So this is the structure, the way the pen is made. Okay, so that is known as a your attributes are filled, the way particular objects are built, are constructed. Second purpose, these objects are why, what are the purpose, why they are used. So pen is used for the writing. So writing is your behavior or function. Okay, so you can take any other example. Let's say a human being. So human being is the one object, and that's have a the couple of elements from which human being made. And what are the use? Human being can walk, run, speak. These are the behavior. So similarly, whenever we are going to create any kind of object in our software, we are going to define this two. One is the your field, and another your behavior or function or activities. What this object do? So this principle encapsulation say we have to ensure some sort of data integrity. So whenever you're going to define any object, you ensure that you maintain some level of data integrity, data security, data validity. Okay, so for this principle say hide the internal implementation details and expose only necessary information to outside world through the public interface. You mean by? So here trying to say, let's you are going to create any, let's say employee the object. So this employee object, couple have a field can be employee name, employee ID, employee age, employee different fields through which the particular employee we are going to construct. And this employee have a couple of behavior. Okay, so couple of behavior. So generally, encapsulation say whenever you are going to define the attributes and whenever you are going to define the behavior, so sometime some specific behaviors are depend on the specific attributes. Okay, so please ensure that whatever the attributes you are defining, that can be, if this is really necessary information, really necessary to access by the outsider, those information you expose to the outer world. But if some are the very critical informations that may be not required, unnecessary, some outside of the box someone can access, you can say that hide them, or you can say protect them. Okay, and this principle ensure that we are not violating the data integrity issue. Anyway, while the system design, this encapsulation help us to reduce coupling and improve the modularity. Okay, so maybe a good option. Let's talk basic some example so that you feel comfortable as a software programmer. What do you mean by data integrity? How this encapsulation principle ensuring that we are going to create any object that's look like a real, not like a fake object. Anyone can create the fake object. Like, so let's example. Okay, so let's example. So here we have a let's simple class employee. An employee can have a couple of fields. Maybe you can say like employee name, age, salary, everything, right? So it's good. So generally, if you are defining this like a field, if you writing this like a class simple, so this class have a simply one employee. An employee is each and every employee can have a name, can have a age, can have a salary. Okay, it's good. So let's also integer employee ID. Okay, it's good. So as of now, so how this is the simple way in Java you can create your employee class, and from this class you can create any number of your object, maybe employee 1, maybe employee 2, maybe employee 3, maybe employee 4. Okay, simple. So let's here I'm going to create employee 1 equal to new, and here you can say employee. So notice here we have option, you can create the employee. So if let's you set the value, hey employee, if I'm going to the print, that's out print employee. So what do you think? These are the really valid employee. This employee have nothing. I'm not specifying any kind of name, any kind of ID, any kind of age, but still we are able to create the employee object. So look like this is the employee, but this is not actually a valid employee. If you run, they are printing something garbage value. Okay, so even instead of they are just printing the highest score of number. So this is also employee class, but this is not as per follow the guidelines of encapsulation. Okay, so they are printing something. So even that's to string. override public to string. Okay. Okay. Override and just say, hey, IntelliJ and just generate to string with all the prints. Okay. So now we have an employee, and now if we run here, they are creating object, but notice this object is not generally real. What is the meaning of any employee? Zero, null, something zero age? There is an employee. Reality is not, there is no any employee with a zero age. So somehow, as a program, support you can create object, but it's not look like a real. There is no data validity. So somehow I want no one can create the object like this. So we can say, hey, let's go make a private constructor. So hey, private constructor. So whenever I'm write this way, so even as of now, at least our compiler fail. Hey, you cannot create the employee like this, because I'm not allowed anyone can create the employee like this. So what other option? So, okay. So that means while creating object, I want to take some input. So here say, hey, I need create another insert constructor. Let's create our constructor and this value. So now we are going to create constructor. At the time you have to must put this value. Okay. So here I'm going to say now the employee ID 1, a name John, something. Okay. So now at least we are able to create employee object with a specific value. If you run, now at least we have some employee. It's good. Now we are going to create the employee object that have a at least the name, age, everything. Okay, that's great. So what happened? Someone say, hey, employee 1 dot let's age equal to 300. Okay, and after that let's again read it. So notice our employees are valid, but somehow the data they contains maybe 3000 or something that's are not really valid. Our employee cannot be age more 300. Employee have a logical age. So somehow we have not any restriction to ensure the object created that's with a valid value. So I'll do that. So there are a couple of ways. One way, here what happened? The employee object, we are going to allow hey age field. Anyone can access. So age is my critical information. So I don't want anyone can access outside. Means this is my class. Inside this class, you can access this age attribute, but outside of this class, I'm not allowed. So here I don't want to allow. So how to just again say, hey, I am going to make as a private. So once you say private, that means now this is not accessible. Okay. Now at least this is not accessible. Okay. So next question. Sometime I need to update the age. How we can do? How we can do? Question is that. So again, here the definition of encapsulation tell us, hey, you have to hide the implementation detail and expose the necessary information outside our through the public interface. So somehow we have to expose some function. Let's say this is the age, and now I am going to say, hey, some public method like a set age. Okay, and set age is going to age, and here you can return your prompt. So while I'm going to set age, I'm setting, hey, any employee age greater than at least 18 and less than only allow be 65. So now our system is allowed to set the only this valid value. So this is only possible if whatever the important attribute for age I am making as a private, means hiding from the public accessible, and allowing anyone can change, update the value in the proper method. And in this method we have an option, we can write our business logics, what kind of a valid value I want. So now here, now instead of that I can say, hey, let's employ one dot set age, and let's say pass to 2000. So what do you think? Is really able to set it? No, because our restrictions say, hey, you cannot modify. Maybe you can throw exception, hey, these are the not valid exception. Maybe you can throw exception, hey, age cannot be, you can say, hey, else okay, else invalid age. So somehow through exception or mention, hey, this is the invalid age. Can you provide the valid value? Someone. Okay. So in this way, you are ensuring that, hey, someone really want to do something, then okay, employees cannot be greater than something. Okay. So in this way, you are going to ensuring that whatever the employee class or any class object, that's are very critical, just make as a private, and if you want to someone, anyone can modify it, edit the value, then make a public one functions or method, and that method apply your business logic and restriction. So this is the now our employee class for age specific field is become a kind of a encapsulation. So it's generally whenever you are writing any model classes, make every variable as a private so that no one can access from outside, and if some specific variable you want to modify, then you can allow. So generally all these variables should be public. Okay, so now this my class follow the guidelines of encapsulation. Every fields of this class is a private, and if a specific things you want to provide, someone can edit, someone can modify, then you can go and provide the some public method and put your business logic, put your constraint, so that you can say, hey, our whatever the employee object now someone going to create that would be look like some reality, some valid. Okay. So encapsulation help us to ensuring that whatever the object going to create in my system, that's look like as real as the particular business model. What kind of a reality, particular object have some specific attribute, a specific value can be allowable, those things we can restrict. Okay, so this is the principle which help us to ensure that we are encapsulating whenever we are building any object, the data and the method in the single unit. Sometimes encapsulation means here your variables are filled, whatever the field you have, make this is the private, and make some public function, public method that can maybe returns or that can be allowed to set. So if any field which you want to restrict, just make a private, and if you allow some public method that return the value or can be allowed to update. While updating, you are ensuring that you can apply the business rules and restrictions. Okay. So this is one of the basic and a key principle of OOPS. Okay. Let's talk the next. Next is also kind of things were known as inheritance. So inheritance is the kind of principle where say, hey, if we have a one object already created and I want to create another object, but the similar kind of behavior plus additional more. So now I am going to create another object that have a two behavior, a plus additional more feature. So somehow why I am going to write this two line of a behavior or function again and again, just I am inheriting them from the this is known as your parent, this is another child or superclass or subclass. So somehow inheritance is the process by which we are inheriting the attributes behavior of another superclass inside your subclass. And so there are some rules, lots of rules. We are not going to talk all the inheritance rule, but couple of rules. Only the public member variables are filled can be inherited. If let some variable mark as a private, so private data member cannot be inherited in the subclass. If anything you want can be inheritable, that's data member, a variable or method that must be in a public, or some scenario it should be protected. So protected data member within a package can be inheritable, but public is inheritable across the packages, across the folders. Okay. So inheritance also, there are a couple of types of inheritance. We are not going to talk more detail, but here while designing your system, we have options. If we have a one object already and similar kind of things I want to reuse in a different manner, yeah, let's we have a one behavior. I want to, this behavior must be different for a specific purpose and other would be the same. So other two behavior would be the same. Third one I want to change as per my requirement. So I can maybe change the definition using the different way, using the overloading method. So inheritance can have give a capability where we can reuse the existing behavior, existing methodology, existing function in the different contexts. And even we can overload and override these other concepts. And inheritance are in a different programming language have a different approach. Maybe some inheritance is your superclass, public data member or attributes can be inherited in the subclass. This is the one way. One way the multi-level. This is the inherited from this top level and again can be inherited in the sub top level. So here multi-level of inheritance can also supported in the multiple programming language. So this field can be inherited here, he can be inherited here, can be inherited here. So this is a single level inheritance, this is a multi-level of inheritance. Sometime might be we have a one class and that can be inherited by the separate hierarchy. This is the one class can inherited, this is the one class can inherited. Might be this behavior can be overridden in the different here, a same behavior can be overridden in a different here. So this is also known as your hierarchical inheritance. Similarly, some programming language can support kind of a multiple inheritance. Like this is the one class and we have another class and can be inherited by the one common class. Okay, so this programming language. There are a couple of programming languages like C++ support this concept, but like other programming language, Java and other many programming languages, they are not supporting the multiple inheritance. Means one class, one object cannot be inherited the property from the multiple classes. Okay, so generally this single inheritance, multiple level inheritance, multiple types inheritance are hierarchical interface. Some are the hybrid kind of interface. So all these things are you can just go through, but these are three are majorly used by the all programming language. But this multiple inheritance like from multiple classes and can be inherited by the one common class. These are the rarely, but specific programming language like a C++ support these, but other programming language cannot directly allow. Okay, but some scenario where Java, if you talk about the Java is going to support multiple inheritance in the form of not class, but in the form of inheritance. We'll talk later whenever we have time for that. So if you want to really multiple inheritance concept, instead of class, you can use the interface. Interface allow multiple interface can be inherited by the one interface. Okay? So good example, you can just I'm not going to give the code level example. It is very simple. Just you can go and write the inheritance code in the Java. Okay, so this is a very inheritance feature, and one of the also kind of a extension of the inheritance. If first we are going to use the property of inheritance and your class inheritance by the subclass 1 and same inheritance by the subclass 2, right? Yeah. So one more level of additional feature of the polymorphism, and that's it. Hey, whatever the behavior defined in the superclass, we can override. We can give the new definition in this subclass, new definition in this subclass. So maybe here kind of one top interface like a shape. Here shape can be, I'm going to drawing shape, maybe a rectangle shape, maybe square shape, maybe a semicircle shape, different shape can be. So one behavior can be overridden with a different subclasses, different meaning. Okay, so here design object on a multiple form means the one object can be treated different behavior depend upon the which subclass you are going to inherit. Okay, this is generally achieved by the method overloading and overriding. This is also very simple principle. Just read out from the any specific website and they allow. So here just meaning over riding and overloading. Overloading means ki, whenever we have a one method and similar method you can define in the with a different parameter. Remember this method like a sum. Sum will take one argument, and you can define another method like sum that will take a two argument. So this method name can be same, but the input parameters must be different. In this scenario known as a method overloading. Overriding, where you can going to define one method with the same signature, but similar method you are going to define in the subclass the same signature, same input, same method name. This is known as a overriding. Means here you have a function 1 with a no argument. Here we can also define a function 1 without any argument. Here also define a method 1 without any argument. So such scenario where the super class have some method and same method, same signature you are defining the subclass, that is known as a overriding. So overloading and overriding help us to implement polymorphism. Polymorphism means we have a one object that can have a multiple form. So here our sum function are printing the sum of only 2 digit. Same sum function can be sum of the 3 number, maybe sum of the 4 number. Okay. Similarly, can have one shape. Shape is the one method can be shape drawing shapes. One shape can be draw circle, one shape can draw with rectangle, one shape can be draw triangle. So here overriding means defining more than one method with the same name and same input parameter known as a overriding. Whenever defining the same method with a different input parameter known as a overloading. Okay, so if you want to talk more detail here, you can already will discuss, but these are the very simple things. You can just look and overview what are the polymorphisms. And now one of the key concept I am going to talk about the abstraction. So here abstraction is very whatever the we are going to the design system. Let's talk more about the high level. More our key feature, our important feature. Just don't go talk more detail about the internal implementation of how internal work, because while system designing you are mostly we are talking the abstraction, high level the concept, high level the approaches. Here you can say defining interface or contract that specify how to interact the object and without losing the internal work. So here we're not exposing more details, you can say, just very important high level concept. We can, so that the intention of the design should be clear. So we cannot, let's jump. We are going to design a system. At this system, we are exposing lots of behavior, behavior 1, behavior 2, behavior 3, behavior 4. Might be this all the behavior are not so important. Still we are exposing. If particular client going to use this, they have a lots of contract, lots of method available, which they are going to the call. Maybe they confused. So might be we can lose our actual intention why we design the system. Our system is designed for very specific purpose. So we can just expose as very important functionality. Hey, this is a very important functionality. I am exposing only one, and rest I am going to just hide them. Hey, this is a private or someone internal system can access this all the behavior, but outside of systems are I'm not going to expose any kind of unnecessary methods. So this is known as abstraction. This abstraction is we are exposing very important, very essential information to the outsider, and but which are the not so important to the public. Those are just make as a hide, or make as a private, or make even we are not defining in this higher level of abstraction. So generally abstractions is talk more key important features that are really used, and all other that are not so important, don't expose those things. And these all the, you can say, principle, whatever we talk, that's help our system while designing make more maintainable, and we can going to make our applications, our system more maintainable and more modular. So these principles, these are very basic principle. Maybe you can just read out, but we should aware why I'm talking this very basic principle, like your encapsulation, inheritance, polymorphism, and abstraction. Because whenever you're talking with your colleagues while the system designing or discussing with the QA or customer, we are not many times this terminology we are used while the talking the system design. Whenever we have some diagrams, and in this diagram, hey, this is the here these two models are going to be the inheritance principle. So we should know what do you mean by inheritance, what are the purpose of inheritance. Hey, here I'm going to talk about the abstraction, so we should know what are the abstraction. Hey, here I'm going to implement the polymorphism, so that different kind of like here payment processing system, and payment can be implemented not just a specific bank but the multiple bank agent I'm going to support. So here instead of talking more detail, here's a hey, our payment processing systems are going to implement it by the here polymorphism feature, so that the processing of can be depend upon the different mode, maybe credit card, debit card, internet banking, different way I'm receiving the payments. So we should know these terminology like encapsulation, inheritance, polymorphism, and abstraction. These all information, all OOPS principle help us to design more modular and more maintainable system. And this terminology help also whenever designing system, and later part these are going to actually implement by the developer. So developer also know, hey, these are the here we have to going to implement the inheritance, abstractions, or polymorphism, or you can say inheritance. So while the lower implementation level, low level designs, these are the very clear, and high level design also very clear. So these are the very basics OOPS kind of a feature we should aware, and we have to know, we have to understand the meaning. And these basic principle, encapsulation, inheritance, abstractions, polymorphism, many places will play very crucial roles to implementing your designs. So we as a system designer also know the high level concept and low level designing. When we are going to implement these principles are directly implemented by our junior engineer or the implementation or the developer. So for both high level design and low-level designs. This terminology, OOPS principle, play a very important role in the system designs so that our systems become more modular, more scalable, more flexible, more maintainable. These things we can easily, our code easily get if we follow the OOPS principle. Easily you can maintain the code. Easily you can make the reusability of the components, right? So these are the key features about this OOPS principle. So let's explore more detail. If you not, as if you already know this, this is very good. Now you are at least the basic steps of your system designing you started. Okay, hope this information help you. Thank you for watching this.